This is assignment 37. We're doing exponential modeling again, but this time there's going to be different types of compounding. So we're on page 21 again, assignment 37. So this first one, the simple percent growth and decay, this is what we did during the last lesson. You're given a principal amount, you're giving an annual rate, and you just figure out what this is. Now, the next one, periodic compounding, is a little bit different. And just write this down. That way you'll know what you need to look for. So most often you'll be given some type of rate, usually a yearly rate, but then you'll see the word compounded. Compounded at some other number. Compounded monthly, compounded something else. Okay. Now, going off of that compounding, now we have something called continuous compounding. And you'll know it's continuous compounding because the word continuously. Now, these last two kind of go together. There's half-life formula and doubling formula. Half-life you've probably heard about in science. A lot of times they use that with medicine. You take a certain type of medicine and then they determine how long it takes for half of that to be left in your body. Same idea with doubling, except they're determining how long it would take something to double. So we're going to use these formulas. We have 1, 2, 3, 5. I believe we have 8 problems. It's really important that you try these problems and you follow along. Otherwise, you'll be a little bit lost. This is one of my favorite lessons because it's real life math. So let's take a look at exercise number 1. It says, how much would a $1,000 investment, that's our P, at 2% yearly rate, so our R is 0.02. Oh, this is bothering me. I have to put what the P is. Be worth in 20 years, and that's our time. Show calculations. This is our simple interest formula. So I'm going to write my formula. A of t equals P times 1 plus R to the T. So we have 1,000. 1 plus 0.02 is 1.02 to the 20. And when I put that in my calculator, I get $1,485. 0.947396. When we're talking about money, we round to 2 decimal places. $1,485.95. Pretty good growth. Now, for the rest of these, when we're dealing with money, I'll just go straight to rounding to 2 decimal places. Okay, number 2. It's the same scenario. Okay, same principle, same rate, except this time it's compounded monthly. So when we look at this problem, we have $1,000 invested at a 2% yearly rate. So R is 0.02. Compounded monthly, be worth in 20 years. So that's our T. Now I'm going to write down the formula and then we'll go through what it means. So we're using our periodic compounding formula. It's P, and I got this off the page before, 1 plus R over N to the NT. Now we know what the P stands for. We know what the R stands for. The N stands for the number of compounds. That's a D. So it's a yearly rate, okay, but it's compounded monthly. Since there's 12 months in a year, that means our N equals 12. So now I'm just going to plug everything in. So I could say A of 20 equals 1,000. 1 plus R, 0.02, over N is 12. And then N times T is 12 times 20. If you want to write 240, you can. If you just multiply that in your head quickly, that's fine. And then you very carefully type all of this into your calculator, and you get $1,491 $1.33. Remember, the decimals are much bigger, but I'm rounding to 2 decimal places because it's money. Exercise number 3. This one, same idea. Our p-value is the same, our rate is the same, but this time we're compounding daily. And we still have 20 years. So instead of monthly, which is 12 compounds, daily, there's 365 days in the year. So I'm going to use the same formula as above, and I'm going to write it because we should always write what formula we're using. It's like an introduction sentence to a paragraph. Okay. So our principal is the same number, 1,000. 1 plus 0.02, same rate. This time, instead of a 12 for an n, it's 365. And then n is 365 times t, which is 20, running out of room. So you carefully put that into your calculator, and I got 1,491.81. Last one like this. We still have $1,000. Still a 2% yearly rate, but this time it's compounded continuously. Now, continuous, remember we went back through in previous lessons that number E, and I said in class, it's just kind of this naturally occurring number, because in nature, a lot of times things happen continuously. Well, if you're really lucky, maybe you have an interest rate that compounds continuously, kind of like our federal debt. It's in the trillions. You might have seen, I'm getting off on a tangent, you might have seen like in Times Square or someplace, they show the federal deficit and it's just constantly going up. That's interest. Anyhow, we're going to use this formula. A of t, we call it PERT, P times E to the RT. R and T are exponents. Here's our P. Our rate is 0.02%. That hasn't changed 20 years. So 1,000 times E, exponent is 0.02, and time is 20. And because this isn't just a plain number, I will show you how to put this in your calculator. Put the recording back on so I don't write. Okay. So hopefully you guys can see this. So it's 1,000. E on the graphing calculator is the second divide by button. I'm on Desmos. I'm not at school. I'm at home. Okay, here we go. E. And then there's e to the x. Let's try this one. And it already makes an exponent for you. So I'm going to type, I need to go back to my main, 0.02 times, oh, hey, what the heck? 0.02 times, oh, see, when I do times it, that's weird. 0.02, let's see if we do parentheses. Okay. There we go. And you see we have $1,491 and about 82 cents. Remember, if you're using a graphing calculator, it is the second divide by button, I believe. Okay. Now, just one thing to point out. It's not as noticeable here, but I want you to just take a look at these numbers. That's compounded monthly. I guess I could go up to the regular. 1485 is compounded yearly. Okay. Compounded monthly. Can I fit them all? Compounded daily. It went up a little bit, like 50 cents. Compounded continuously, went up a few more cents. The more you compound something, the more money you make. Or if you're losing something, the more you lose something. Now we're just talking about $1,000 here. But imagine if you had $1 billion. Money makes money. So keep that in mind in real life when you're looking at interest rates. Okay, last one. And this one is different. last one on this page, I should say. A bank account starts with $3,000. So over here, I'm just going to write P equals 3,000. The amount decreases at a rate of 5.5%. So it's negative 0.055. I move my decimal 2 places left per year, compounded daily. So we have a yearly rate, but it's compounded at a different amount. So I need my N. So in a year, compounded daily, it's 365. How much will be in the account after 4 years? So T equals 4. So because we have a yearly rate compounded in a different way, we have to use our periodic compounding formula. P times 1 plus R over N to the NT. So we have 3,000. Now this time we're losing money. So you can do this. You can do 1 plus negative 0.055, okay, over 365. I guess I'll just finish this whole thing. 365 times 4 from a previous problem that scooched in there. You can do that, or instead of plus and negative, you can put a minus there. It's fine. It means the same thing. So you carefully put that into your calculator and you get 2,407.516484. So I'm going to say $2,407.52. Okay, 6, 7, and 8 on the next page, we're talking about half-life and doubling time. So we'll be using the last two formulas. I don't know why some things move and then some things just stay put. Kind of annoying. Number 6, a new motorcycle is purchased for $22,000 over time, and its value depreciates by 1/2 every 3 years. What's the value of the car in 10 years? Now, you know it's a half-life because it depreciates, so that means it gets smaller by 1/2. That's your indication you're using the half-life formula, which is A of t equals P times 1/2. You can use 0.5. It means the same thing. And this is T over H, T divided by H, in the exponent. T is time, H is half-life. So let's take a look at this. So purchase for $22,000, that's our principal. When you take out a loan, they'll use the word principal. That's how much you're taking out. So it depreciates by 1/2 every 3 years. Half every 3 years. So our half-life is 3 and our time is 10. So I'm just going to plug those numbers in here. 22,000 times 1/2 to the 10 over 3. You put that in your calculator and you get $2,182. And it says 0.676, so I'm going to say 68 cents. And if you need help putting this in the calculator, please let me know. Okay, try number 7. It's the same idea. I'm going to pause this, and then when I unpause, I'll have this problem done. So I lied. I'm not going to have it totally done. Copper has antibacterial properties, and it has been shown that direct contact with copper alloy kills MRSA over a period of time. Okay, that's interesting, but it has nothing to do with our problem. The MRSA begins at 8:45, that's our P, killed exponentially with a half-life of 7.52 minutes. So that's our half-life. How many MRSA bacteria remain after 1 hour? Now, your time isn't 1 because the half-life is in minutes. Your time would be 60, as in 60 minutes. So now I'll put that in the formula, 8:45 times 1/2, and our exponent is 60 over 7.52. If you're putting in a fraction in your graphing calculator, you just do alpha y equals, by the way, and that'll give you a fraction. And you get about 4. Basically, it's like 4 bacteria pieces. And the last problem is the doubling. So it's like the half-life formula, but it's a doubling formula. and you can tell we made this up for you guys. The Algebra 2 virus may double every 13 hours. If left untreated, how much Algebra 2 virus would there be after 3 days if it began with 90 units? So our p-value, sorry, it's really lame. P is 90. We're using the doubling formula. Well, let's write the formula down. A of t equals our principal. Instead of multiplying by half, we're multiplying by 2. And instead of t over h, it's t time divided by our doubling amount. So it says it may double every 13 hours. So that means our doubling number is 13. If left untreated, how much Algebra 2 virus will there be after 3 days? So we have 3 days, but our doubling time is in hours. So I'm going to multiply it by 24. And I get 72. So I'm going to plug this in. 90 times 2 to the 72 over 13. And now, unfortunately, I changed this problem, so I have to figure out what the numbers are. So let me clear this. So I'm going to type in 85 times 2. Now, where's my exponent button? I know you're here somewhere. Okay, you know what I'm going to do? I don't even have my keyboard. So here we go. Exponent. Now I'm going to do parentheses. 72. If you want to keep both values in the exponent, you have to use parentheses. Otherwise, it'll try to pop back down. So our answer is 3,950.59. And we're going to do this to the nearest whole number. So 3,951. 3,951 of the virus units. That's a lot of Algebra 2 virus. Okay, go do the Delta math problems, and then the next lesson in class we'll work on the practice together.